Welcome back, Python explorers. Today we're opening the door to the quirky world of Python sets. Imagine a party where everyone insists on being unique. No twin outfits, no repeating dance moves. That's the kind of party sets throw in Python, a collection where each element is as unique as a unicorn, and duplicates are as welcome as a cat at a mouse convention. To create a set, you can use curly braces eyes with elements separated by commas. It's like inviting guests to a party. Each one must be distinct, no twins allowed. Or you can use the set function, which turns an iterable into a set, automatically filtering out any duplicates. In these examples, notice how any duplicate elements are automatically removed. In prime underscore numbers, despite adding 2 and 3 twice, they appear only once in the set. But beware when creating an empty set. Using empty curly braces I'm won't give you a set, but an empty dictionary. To create an empty set, you'll need to use the set function without any arguments. Here, empty underscore set is a set with nothing in it, ready to be filled with unique elements as your program progresses. Sets aren't picky about the types of elements they contain. A single set can hold integers, strings, and even tuples. It's like a melting pot of data types, each element retaining its identity. In mixed underscore set, we have an integer, a string, and a tuple coexisting peacefully. Just remember, while sets accept a variety of data types, they cannot include mutable elements like lists or dictionaries. The primary way to access set elements is through iteration. Think of it as taking a walk in a garden and admiring every flower you come across. We use a for loop to visit each element in the set, one by one. In this example, the for loop takes a tour through my underscore set, and with each iteration, it retrieves a programming language. It's a straightforward yet effective way to process each element in a set. Another way to interact with set elements is by checking if a specific item is present in the set. This is done using the in keyword. It's like asking, "Is this item part of your club?" Here we're checking if Python is one of the elements in my underscore set. The in keyword makes it easy to confirm membership without iterating through the entire set. While direct access via indexing is off the table, sets offer several methods to interact with their elements. Methods like pop can be used to remove and return an arbitrary element from the set. Remember, since sets are unordered, you can't predict which element pop will return in this snippet. Pop removes and returns a random element from my underscore set, demonstrating the unpredictable nature of sets. It's like drawing a random card from a deck. Sets in Python come equipped with a suite of operations that can perform complex data manipulations. These include unions, intersections, differences, and more. It's like having a toolkit for solving puzzles, where each operation helps fit the pieces together in different ways. Each of these operations serves a distinct purpose: union for combining, intersection for finding commonalities, and difference for contrasting sets. They transform sets into a playground for data analysis and manipulation. Beyond these operations, Python sets offer a range of methods that allow for more refined manipulations. You can add elements with add, remove specific ones with remove, or discard elements without causing errors with discard. These methods enhance the flexibility of sets, allowing you to tailor them to your specific needs. Whether you're building, pruning, or reshaping your set, these methods have you covered. Just when you thought sets couldn't get any more interesting, let me introduce you to their steadfast cousin, the frozen set. In the world of Python sets, a frozen set is an immutable version of a set. It's like a set that's been frozen in time. You can look, but you can't touch. A frozen set has all the characteristics of a regular set, but with one key difference. Once you create a frozen set, you can't add or remove elements. This immutability makes frozen sets reliable and consistent, ideal for situations where your set of elements must remain unaltered. Here, immutable underscore set is a frozen set containing 3 fruits. Try as you might, you can't change its contents. It's as steadfast as a rock. One of the strengths of sets in Python is their ability to conduct membership tests much faster than lists or tuples. This is due to the underlying hash table structure of sets, which allows Python to determine if an element is in the set without having to check each item sequentially. In this comparison, while both the list and the set contain the same elements, the set performs the membership test more rapidly. This efficiency becomes particularly noticeable in cases of large collections. While sets in Python are powerful, they have a limitation. A standard set cannot contain mutable elements like lists or other sets. However, you can create a set of immutable sets, often using frozen sets, to achieve nesting. This is like building a stack of safes, each holding its secure content. Here, outer underscore set contains 2 frozen sets. Each frozen set is immutable, making it a valid element of the outer set. This approach allows for the creation of nested structures while adhering to the rules of sets. Moving on to set comprehensions, they bring the same ease and readability to sets that list comprehensions bring to lists. It's like writing a succinct poem instead of a lengthy novel. Both tell a story, but the poem does it elegantly in fewer words. In this snippet, we create a set of squared numbers using a set comprehension. The syntax is similar to list comprehensions, but with curly braces. It's an efficient way to build sets dynamically, and that concludes our exploration of sets in Python. With their emphasis on uniqueness and a suite of powerful operations, sets are an indispensable tool in your Python toolkit. As you continue to explore Python data structures, remember that sets offer a distinct and efficient way to manage your data. Stay tuned for more episodes.